setting up, maintenance, and all that kind of stuff could be a lot of work. Um, so that's why, like, we just wanted to focus on like, what is vanilla Kubernetes, like, what it gives us, and also like what does Azure does, like, what Azure Kubernetes Service is, like, how does it make it much easier. um, Before that, as you know, this is SAC Azure group. Like, we meet every third Thursday of every month. We try to keep the conversations like very casual, and we know that a lot of people come, like, different from different backgrounds. Some could be like, very technical, and some could be like, just learning, or we just want to focus on like in all the people who are attending. Uh, so the topics, like, for this one, like, I just wanted to keep it like, um, I want to give an experience of Kubernetes, but then I want to keep it simple. If, let's say, like, you want to know more, or like, I can do a deep dive on like things like service mesh, or things like, Helm and all those kind of stuff. But then for this one, like, I just want to go over what is Kubernetes, like, what does AKS does for us, and deploy a simple app, and get it working in Azure. Having said that, so I'm presenting this today with my colleague, Josh Petla. So Josh and I, we both work for Slalom. I've been working with public and private sector clients for the past like 17 years. So I worked with a lot of state agencies. I worked with a lot of private. So and I'm from a development background. So when cloud started, so I was so excited because cloud made a lot of things so simple, and also like a lot of things very easy, and like very straightforward. So that's when I jumped onto cloud, and I got into AWS. I also in Azure. So um, so I'll let Josh introduce himself.
Thanks, Uday. My name is Josh. I have over about 14 years of experience within the IT role. I started as a web developer right out of the college, like WordPress web administrator, creating custom websites, and then ventured into being an Oracle DBA. And then I realized my passion is about leading teams, being that technology thought leadership, which is when I focus my strengths to kind of help teams, bring people together, form teams together, help our clients achieve the best possible innovative solutions. So that's what I find my passion is, and that's what I've been following along since then. I've been in the cloud area for about 4 years now. I started with AWS because that's a need at that point in time. That was I was requested by because to lead a group of cloud architects for this particular key project. And since then, I've been in AWS, but now I see where the world is going, and Azure is also being very competitive right now within the cloud space. So it only makes sense for me to also be familiar and get my fingers within Azure cloud as well. So I'm base Azure certified at this point, but I'm planning to do a lot more in the Azure space as well. So this is one of my other ways to get into Azure cloud space as well. That's me.
Um, so before moving further, like, Kyle, would you mind recording the session, please?
It's being recorded.
Yeah, it's recording.
Okay, sure. Thank you very much.
Mm-hmm.
All right, I can quickly go over. So since it's a good thing, Kyle, thanks for asking the icebreaker around what's our current experience within this group. So it might actually make sense for the group to kind of learn about, do a quick refresher on current or traditional monolithic architectures and microservices. How are they similar? How do they differ? Also understand the limitations of monolithic architectures. And then what are the limitations are will eventually be the benefits for microservices, right? In that lens. And then also talked about some principles of doing microservices architectures. And after that, Uday is gonna go into explaining about Kubernetes, a flavor that can offers microservice architecture from Google. how it is, and kind of discuss various components of Kubernetes and some sample architectures and a demo. If you can go to the next slide today.
Sure.
All right, let's look at the section on the left. You guys are, all of you guys are familiar with this. It's a monolithic architecture is a traditional software design practice where the programs and software applications are supposed to be self-contained. As you know, if you focus on the diagram over there, all the components that you're developing for an application, everything will be divided into up to these four layers: presentation layer, service layer, persistence layer, and the database. So it doesn't matter if you have 10 different modules for a software application or one. All of those will fit into this particular a tiered architecture, if you will. So at a high level, that's a monolithic architecture. And let's see how microservices architecture differs from monolithic architecture. So microservice architecture is something it's relatively, I wouldn't say new, but newer, but it has been there out there for a while. The adoption is at the early stages, the adoption were very slower, but then as the big companies like Amazon, Netflix, have been adopting this microservice architecture, and people have been realizing the benefits. I was actually hoping to put some numbers together and stats around what percentage of organizations are moving towards this. Unfortunately, I didn't get enough time, but I will follow up in this on the Slack channel of those references. But definitely, the private sector has been driving this particular microservice architecture a lot faster. And what is it about? It's very loosely decoupled, usually coupled, or other words to say is like decoupled components. For example, if you have an application that you're planning to build that has like invoicing, accounting, payment, account creation, each of those modules will have its own microservice, will have its own database, so that these particular components can function individually without having to rely on other components that are being built. In the next slide, I'll talk about how monolithic architecture will have issues in such modern development methodologies. But at a high level, this is what you're looking at. A microservice architecture is a function based, which have its own stack, its own database, and it's decoupled from the other modules that your application you're planning to build. At any point in time, if you have any questions, please stop me, and I'm happy to answer or post in the chat. Okay, let's look at the limitations of monolithic architecture. So the first one is lack of agility. So what does it mean that? So traditionally, you would have a development team, database team, middleware team, testing team. So in a monolithic architecture, how the operations of development will go along is the development team will build their code, the database team will do their own development, middleware has to make sure that layer is also developed and properly operationalized. And as you can see, different teams working in silos, which means that the development timelines will become slower because each team will have to spend their own cycles building their own the portion of the software application that they're responsible for. What that will look like is the go-to-market will be slower. Meaning, if you're in a high-paced environment, if you want to roll out your features so faster, if you're focusing on such different teams working on different modules as part of your application, and they have their own different cycles and different timeline, that would actually cause a lot more delay and slower. Given we are saying it's slower because there are modern ways to develop using microservices. So that's why you want to look at it. Fragility, it's highly coupled. What that means is that they're very fragile in terms of, let's say, if an issue comes up or if a requirement is changed for module one out of four modules, then you got to think about, okay, how it's going to affect the database tables that I'm going to be responsible for this module one. Then you want to think about since I'm since I'm actually focusing on the database level, and these are the 4 tables, how should I map out the primary keys and foreign keys for the other modules that will be in development in tandem, right? So you got to think about these ripples of effects that you got to think about in such scenario. Application scaling. In a typical scenario in a monolith, if your application is growing bigger, you would technically add more servers to facilitate that ad hoc. Versus in a monolithic architecture, you can actually control it at the software level, which is much more faster. Instead of deploying, launching a new server, making a copy, and if it's in a typical data center, then that's something on you which might take up to a week, depending on how complex your infrastructure is. Continuous deployment could also be an issue. Let's say I'm going to talk about continuous deployment and development issues together. If you have a bug that you've seen and you want to test out in different environments, and it's a critical production bug, then you got to take the system down and then figure out, okay, what is causing it, and you will have sequentially go through it before that bug is fixed. Let's say a bug could be like your PII data is being not encrypted or is being visible in this particular location on this particular UI on module 2, right? So those are things you're thinking about, but you have to take the system down and then debug and go through, okay, even though it's in user account creation where you have the PI information being exposed, but this application also have invoicing and accounting. Since it's a monolithic, you have to take the whole system down, the server, and meaning that those services will also be down in the meantime while you working on fixing this PI critical security issue. So those are the typical ones which you can avoid in a microservice architecture. How that would look like is you will have your own service level stack. So let's say if account that has PI information is being visible or there's a vulnerability there, you can just take the service down. You can still have your accounting and invoicing up and running. So those aspects of the system will not be affected at all. So that's how you can manage in a better way so that your users are getting the most of your system versus getting nothing at all. The other key one is also depending on a technology stack. So since it's service-based and decoupled, you will be able to choose the right stack for each of the service. For instance, for module 1, let's say accounting, you do want to use a .NET technology stack, go for it. Just do it. For module 3, for invoicing, if you want to go with a Java stack, yeah, just go for it, do it. So there's that flexibility there depending on the module and the service you're planning to deploy. This also goes into the next item talking about is onboarding. Let's say you have a .NET team member and their passion is .NET, but your application stack is in Java. It might not be a good match for your team in the sense like you do want to have they'll take some time to onboard them. There'll be some learning there on the stack, in a monolithic architecture. However, in a microservices, if this person coming in with a Java stack, then they should be able to build this new module with this new stack on their own. So that gives you that isolation and also flexibility. And there is no one stack dependency in a microservices versus in monolith. You have to pick a stack and stay with that. Frequent downtime, which I kind of talked about earlier briefly, but so these are like limitations of a monolith architecture and the benefits. All the limitations, just turn them to positive. Those will become the benefits of a microservices architecture. Any questions on this so far? All right, let's go to the next.
Sorry.
Oh, go ahead.
Inside of each microservices, could we implement the layers architecture? So.
Well, you could actually it's just like you want to have your each layer as different different microservice. Yeah, you want to be like as decoupled as possible, right? So
okay. Thank you.
Cool. Good question, Jorge. All right. So now all the limitations are in fact are benefits. So I kind of there are so many themes, but from my perspective, from what we've seen, these could be the benefit themes of a microservice architecture. It'll help you with agility of your application stack, a lot more increased resiliency. You can do enhanced scaling. Your teams can be optimized as well. If different teams, if a team member is pretty skilled in one particular stack, that's when they can use and build that one particular module for that service, right? Just focus on that. And overall, the productivity, since these are being developed independently but at the service layer level, you can actually have a lot more productivity, and you're not relying on one. The whole system doesn't need to be up and running for all the four modules. If one service is up and running, you can just launch it, have it to the end users, and bring the other service on and add on top of that. So that also provides a flexibility there versus in a monolith, you have to wait all the development is done if there's a dependency there. I think that's what I want to talk about on this one. Let's go to the next one. Next slide, Day. When it comes to principles, okay, now that we've seen the limitations of monolith, and we also learned about the benefit of microservices over monolith architectures, there are, I want to quickly touch on the principles. What are the few principles that you do want to keep in mind as you build them? There are a lot if you go online, but I do want to focus on the key four that actually key in the sense like you got to have these for sure as you if you're planning to develop or plan to build a microservice architecture for your application. Single responsibility. What does that mean? Each microservice must have a single responsibility and provide a single functionality. If we take the same example at a high level, if accounting is a modular building, just focus on that one function. Let's say, for instance, credit card, right? Make that as a service, right? And just make sure that you're facilitating that service to handle or manage those credit card transaction of the application. So that way, if that particular service is down, you can still have all the other service up and running while you work on fixing this. So that's a key distinction or key principles that you do want to keep in mind. The database is also can be decentralized. There is a caveat there I do want to mention. You can say like, well, there are cloud providers are offering managed PaaS services. How can we utilize their benefits because they're managed? And if you want to decentralize them, what would the cost would look like? It all comes down to up to what the business requirements are. If the business requirements are to, yes, let's go with the ideal microservice architecture with a unique database for each service, figure out what is the cost that you're okay with in terms of maybe developing a smaller managed RDS so that you can contain cost there, or going with a long-term purchase of these instances, right? So there are some few nuances there, but it's really up to the right architecture and the cost that you'd want to think about if you want to also decentralize the database level. So there's no perfect solution. The perfect solution is what your requirements are, and that's will actually map to the perfect solution you're looking for in terms of this. And then the second one I do want to talk about is business capabilities. I briefly touched on this. For instance, if a service one wants to be a .NET stack and service three can be a Java stack, right? So there is that capability and flexibility that microservice architecture can provide. The other one is encapsulation. One of the key goals that you would want to achieve is that if each service has its own code base and then the compute level that can interact, and then you have database, the fundamental rule is that make sure if a service one referencing to service B data, then make sure also build an API so that no one needs to know what data is being stored in which table. All you need to know is through the API. This is the data I need, so that service A can query and service B can facilitate that. So essentially, this would actually benefit in terms of it's like a black box. No one needs to know what's going on in the service container from the consumer perspective. All you can get done through standardized APIs. Design for failure. This is a key one that you do want to focus on, which is actually an elegant and a pretty, important feature of microservices that actually help you keep your other components of the system up and running once service gets failed. So that is something you do want to have in mind as you build it. So there are a few other things as well in terms of the principles. I put a bunch of URLs as I did the research in the appendix section. So after this presentation, we'll send the deck over. You should be able to go through them, but I do want to keep touch on these 4 things when it comes to microservices, the principles of that. Next up, we're going to dive into Kubernetes. So Uday, do you want to take it away?
Yeah, sure. So now that we heard so much about microservices, what makes microservices, what helps the microservices is Docker containers or containers in general. So, so the containers, the idea of containers is having a self-contained, it's not an operating system, it's not a virtual machine, like we had like VM, it's more of a it has a runtime library and everything to run an application, right? So that whole Docker containers made it the microservices possible. So what the idea is, you have your each microservice running as a container, and it's deployed into the machine. So so the Kubernetes, so Kubernetes again, Kubernetes. So this is how the traditional deployment has been. If you look at the left part, traditional deployment, where you have your traditional hardware, you have operating system on which you used to deploy applications. Then it changed into virtualized deployments, wherein you have an hypervisor over operating system, and then you used to run you're used to run virtual machines, wherein you have again the runtimes and everything. So and then your applications run on virtual machines. But with the introduction of containers, you have your operating systems and you have a container runtime over the operating system, and then your containers run on top of your container runtime. So the containers itself, since we are not porting the whole operating system, so the containers are so lightweight because they don't need as opposed to virtual machines where you have the full operating system running. But the containers are lightweight, they run the applications and easily deployable and easily destroyable. So so this whole microservice architecture was was possible, and again containers help in that in big time. So where does Kubernetes come in? Kubernetes is what you call as a container orchestration tool. There are many container orchestration tools, but then Kubernetes is by far right now it's one of the biggest container orchestration tool that's being used. So what container orchestration does is since these are so many containers, if you have an application traditionally, you have 20 containers, or you have number of microservices running. So your container orchestration tool makes sure that the containers are up and running. Let's say if the container failed, then then bring up a new container, or let's say if you want to increase the number of containers, all you have to do is specify to your container orchestration tool, and it will scale it up or scale it down. So all the and also the networking, all the communication between the containers, all that, if you didn't have a container orchestration tool, it's going to be hard to maintain all of those. So in that way, Kubernetes comes into your rescue, wherein it orchestrates all your containers running in as containers. So the traditional Kubernetes comes with there could be many things that could be added, but then you have you have two planes, the control plane and the compute machines. So what happens is you divide you the whole Kubernetes cluster. So you call it as a cluster. So it's divided into two planes. One is a control plane, other is the compute machines or data plane, or worker nodes. You can call it anything. So if you look on the left side, this is where you have your control plane. So the way Kubernetes works is it has basically these components, API server, kube scheduler, kube controller manager, etcd. So what happens is, and I'll come to that later, but then right now, so if you look at on the compute machines, this is where what you have is you're having your machines, your worker machines, wherein your containers are running. So in this case, like, and if you look at any Azure or VM, like, you have your virtual machines as a fleet of virtual machines running as compute nodes, and you deploy your containers on top of the on those worker nodes. So basically what control plane does is, like, this etcd component is where, like, you store the information about, like, the key value pair, like, where which container is loaded. So all that information is kept at, like, on etcd, and the controller manager. So there are basically, like, again, like, there are a lot of things that are installed as part of Kubernetes, a lot of controllers which takes care of a lot of things. So all that things are part of the controller manager. And the scheduler is one that schedules, like, let's say if the container is failed, or, like, if you are installing a new container. So all that part is done by Kube scheduler. And your API server is where your entry point to your Kubernetes cluster. So let's say somebody is maintaining a Kubernetes cluster, all he has to do is talk to the API server. So it exposes an APIs wherein, like, you can make calls to the Kubernetes cluster, and get things done. So this is part of control plane. And then in the compute machines, this is where you have all your, like, worker nodes, like the machines where your actual code or container code is contained, all the containers are running. So the components inside the worker machines are, like, the basic component is pod. uh, is a pod is, like, you would say, like, it's it's a grouping of containers. Like, usually, like, you'll have, like, I would say, one container per pod, but there could be many containers. Like, so what happens, let's say you have your code running in a container. Let's say you want to have some metrics out of that container, so then you have another container running as a part of the pod, which you call it as a sidecar. Or you can have, like, let's say, so this is where, like, service mesh comes in. Like, if you are using a service mesh tool, which is it's other topic itself. But then, so you have like, a sidecar container running in the pod. So uh, and let's say you want to have, like anything, like, let's say you have distributed tracing. Like, let's say you want to have, you want to make, like, you look at the calls being made, and you want to see how the communication is happening. So you have distributed tracing for those. Like, there are many open source software like Jaeger, Zipkin. So those provide you a pictorial representation of how your calls are are done. So in order to do that, like, you need another sidecar container running on the pod. So, but then at minimum, you would need one container which will run your code. So that's where you have, and then you have the container runtime, which will run the containers. And your kube proxy is what, like, it acts as a proxy to those containers. So it has all the network related information, like, what protocol and all that kind, what port and all that kind of stuff. So that is where, like, your kube proxy has. And then kubelet is what that communicates with the control plane. So basically what happens is, like, let's say a container failed, your kubelet communicates with the control plane, and then control plane, like, either try to deploy it, or, like, things like that. Like, let's say if you want to have, if you want to scale up containers, let's say instead of 2 containers you want 3 containers, what you could do is, like, you can issue a command to kube API server, and then it talks to the kubelet, and then the kubelet then deploys the containers. So this is, like, and then you have persistent storage. Let's say if you have a storage requirement, like, you have external storage that's needed, so you can have a persistent storage for this containers. Or, like, you can also have a container registry. So your container registry, like, you have Azure like, Azure has a registry, or, like, you have Docker Hub, or JFrog. So all this, like, this is where what you do is you hold you that's like your repository for all your containers. So your kube, so whenever the kube you want to deploy a container into a worker node, so all Kubernetes does is pulls the container from the container registry and deploys it in your compute machines. Any questions?
So you would say, like, kubelet is like the head of the container for that. So would you have, like, a one kubelet for each container runtime, or you have one kubelet managing multiple container runtimes, multiple pods?
I would say like kubelet per machine, but I have to check. Like as far as I know, like it's just kubelet per machine.
Okay.
So, Uday, I may have missed it, but
Mm-hmm.
just at the highest, most basic level, for someone
Right.
who doesn't yet have much experience with Kubernetes or Docker,
Right.
what would the process look like at a high level? Like, say I've got I've got an app that I run on premises,
Right.
use Linux based or what have you, right? Like, so they're gonna first research, how do I Dockerize this?
Exactly.
How do I containerize this application? And they'll first the first hurdle and learning curve is first figuring out how to overcome that challenge, right?
Right.
Um, so then once they've got that, then that's when they can take it and pull it up on their Kubernetes cluster. So when I first started playing around with Kubernetes, like there are so many good labs out there. I mean, yeah, they have like the Coda Cloud and like the ones that are all like already predefined, and you do it through your little web browser window and what have you. But I don't know, if I personally learn better when I do it in a little bit more of a on your own sort of fashion. And there's some
Right.
really good labs out there on GitHub where they'll give you an application and it'll take you through containerizing it, standing up your AKS cluster on Azure,
Mm-hmm.
uploading the image to the container registry, and then pulling it down. And that
Right.
was kind of the avenue I went. And
Right.
then I haven't personally been working with it too much in the wild since then, so I'm a little rusty on a lot of this good info.
Yeah. So like that's why like I have a simple app for demo. Like I have code. I can show you like how to Dockerize, like how to containerize a Docker, like Docker file, and then push the code into registry. So I'll show all of those. But yeah, so as you said, like all in like first place, like you need to Dockerize your code, like make it like as a container, like push it to a container registry, and from there you issue like you try to deploy the container to Kubernetes. And that's where your like CI/CD tools like Azure DevOps or like Jenkins, all this, they come into picture. So all that piece of moving the containers or like building the code and all that piece is done by the CI/CD tools. Like, and also the other thing that comes into picture when it comes to container is like you need to make sure that your containers are like doesn't have any security flaws, like doesn't have any issues with respect to security. Like, so you need to do like the container scanning on, so all that stuff like you need to include in your pipeline. So any other questions, thoughts? All right, moving forward. So what is Azure Kubernetes Service? So you have seen like you have the control plane, you have the data plane. So what Azure does for is like it takes care of all the control plane stuff. Like so what it does is like you don't have to worry about like deploying in upgrading your Kubernetes version or making sure that it's highly available, or making sure things like that. Like make sure that uh, like there are no security issues and all that kind of stuff. So Azure takes that headache out of the managing your Kubernetes control plane, leaving us free with like you can use you can work on your data plane. So what it does is like it's like a managed orchestration service. So you don't, so it's there for you like when it's needed, like and it's highly available, like and then um, and then easy migration. Let's say you already have a Kubernetes workload running, so you don't have to worry about moving your actual Kubernetes stuff. So all you need to do is move your code and all the worker node stuff. And again, like I said, like it's very highly available, highly scalable, and it integrates really well with Azure DevOps. So in a way, like Azure Kubernetes Service, like when like we were talking when we started off this presentation, like um, where like by setting up your own Kubernetes, like it's as I said, it's not it's a challenge, and then like maintaining it, and everything, making sure that it is highly available, and all that stuff, it takes a lot of time and effort. So that part is totally managed like by Azure for us. So then that leaves us as space to do your own code and deploy your code and make sure that um, and it's running, and then and make sure that you have it's highly available and all that kind of stuff. So that's where your AKS comes into your rescue. Any questions? Okay, moving on. So this is a sample AKS architecture that I wanted to show. Like this is from Microsoft website. So as I said, your Kubernetes cluster. This is your Kubernetes service, and this is your Kubernetes cluster that's running, and then that is. That is inside a VNet, which is VNet, which is a virtual network inside Azure. And then you have, like I was talking about, this utility services like Prometheus. Prometheus is a metrics software, so that can run, and then that provides us metrics on what's happening inside the Kubernetes and all that kind of stuff. And Elasticsearch is again it's a search on search tool, and then it can be used for logging and all that kind of stuff. So this is where your Kubernetes cluster is. So what happens is this is where your DevOps has RBAC access using Azure Active Directory into Kubernetes cluster, and then your pipelines, what they do is they create, Dockerize the container, and then push the Docker containers into the container registry, and then your Kubernetes cluster takes the container from the container registry and deploys into Kubernetes. So here we have Helm. Helm is a package manager, which is which makes a lot of things easy for you. Like let's say you want to install Prometheus. Let's say you want to install Prometheus. So it's part of Helm registry. So it makes it easy to deploy Prometheus or uninstall Prometheus or many other different software you need for Kubernetes. Or also if you want to make any changes to the cluster itself, you can still do Helm and use it to for the Kubernetes cluster. And then this is where your backend services are, where you have all these pods running. So this shows pod scaling, and then your external data sources here. So your ingress is it's like your it's like a load balancer that is running in front of your Kubernetes pods. And then that's again fronted with the Azure load balancer, and then your client apps. So it's it's like basic architecture wherein you have different components. This shows how you want to deploy it's a sample front end application, not sample, you can use it deploy your your workloads. So any questions? I think the next slide explains all this. Yeah, go ahead.
I have a question. So let's say if you want to do a monitoring,
Right.
Where do you do that? Would you actually go with, let's say if you go with native, we go with Azure Monitor. If you want to have a third party one, you would install in the utility services section.
Yeah, you can. So basically what we are saying is utility, this is a namespace. So but this container itself is actually you have a Prometheus cluster namespace running, but then your actual all the monitoring that happens as a sidecar inside a pod. You have a Prometheus, let's say you're getting a metrics out of your pods, so Prometheus runs as a sidecar. So in a pod you have your code running, and then you have another container which has Prometheus, so it scrapes out all the metrics from the container.
I see.
Yeah.
So all those namespaces other than backend services, Azure is maintaining it as part of the AKS.
No, those are all we create those. Right. So anything with respect to worker nodes, we do it, right? So we I think this is more like a grouping, like namespace, So again, Kubernetes works in namespaces. I need to say this, but So what happens, you can group things together. Like let's say your front end is a namespace, right? So you install all your front end stuff or containers, everything in that namespace. Back end is another namespace. Utilities is another namespace. So, and again, like, your Kubernetes, I'll show you when we get there, but then your kube system is another namespace wherein you have all your Kubernetes stuff going on. So that's how like Kubernetes manages, like, or you, like, it's more like, you manage, like, different things inside the Kubernetes cluster.
Okay, thank you.
Are you gonna show that sort of stuff, Uday, or?
Yeah, I will show that.
Okay.
I just need to look at the time. Yeah, okay. So the next slides basically, like, they talk about like ingress controller. So I think we already touched upon all this: virtual network, container registry, pipelines, Azure Monitor. So this is Azure Monitor is where, like, you have your metrics and logs. So this is Azure native tool that you can set up alerts or dashboards and all that kind of stuff. So that's done by Azure Monitor. Again, Azure Active Directory is like for authentication and that kind of stuff. So yeah, so I think we are ready for demo now.
Well, so real quick, I want to point out all of those things you just flipped through.
Mm-hmm.
If you guys, if you imagine, like, if you're standing up your own Kubernetes cluster, right? Like all these ancillary services that you get by using AKS, you'd have to be deploying as utility services down there. So the complexity is already vastly greater by managing a Kubernetes cluster. But then to top it off, like once you want to integrate all that stuff, it's that much harder.
I would say, like, it's complex, but it's not hard. This one, like, think about, like, setting up your whole cluster itself, like,
No, I'm saying that using AKS, that's one of the major value add and selling points, that all of those ancillary services are pretty well integrated out of the box. So it saves you a lot of complexity and time and overhead of having to deploy those yourself.
Yeah. Like all these services like Monitor or Key Vault or Active Directory, all this, they work out of the box. Like let's say you're creating your own cluster, then think about it, like setting up all those and making that work, and it leaves it takes out a lot of headache for you if you want to do Kubernetes and microservices.
Yeah.
Yeah. So.
Uday,
yes.
This is Raja. You were talking about sidecar approach or something. I didn't follow. Are you referring the multi-container approach there?
Yeah. So the pods, like, so as I was talking, like in like Kubernetes, you have pods, right? Like pod is where, like, it's a grouping of all the containers running inside worker nodes. So the sidecar is like, you have your other ancillary services, like, your Prometheus or your Jaeger or like any other. Like let's say you want to have running, then you run it as sidecar.
Within the same pod, is it right?
Within the same pod, yes.
Good, yeah.
Yeah.
Thank you.
Any other questions? Okay, so let me quickly go to the demo. So obviously, like, there are so many things to talk, and it's it's complex by itself. So I just have a simple app, like, simple .NET .NET Core application. So all it does is, like, I'll show you .NET run. So.
And I think you're just seeing your PowerPoint.
Oh, you're not seeing the PowerPoint? Sorry. You're not seeing my.
Yeah.
Sorry. Okay, let me. Thanks for pointing out.
Uday, are you on a Mac or Windows?
I'm on Windows. So
I'm over here secretly hoping you're going to open a Windows terminal with a custom background image.
So let me know when you guys see the screen.
Yes, we can.
Yeah, so this is the Visual Studio Code. So I have a sample app running, right? So it's a simple .NET Core app. So I have the terminal open. What I do is .NET run, which would, it's a simple web page. Let me show. So it's a simple web page. Like it shows like the meetup. So this is what it does. So now coming to sign in.
Security breach.
Okay. Now, okay. So now we saw the application running. So it's up and running. So it's simple app. So what do I do to Dockerize it? So this is where your Docker file comes in. So I already have Docker installed on my machine. So I need that to do the Dockerization. So this is a simple Docker file. What it does is, if you look at from here, like it pulls out like so this is a container image that is pulling. So this is a public .NET 3.1 image, a Microsoft image, which has a .NET Core 3.1 inside it. So your application run it. So and then what it does is like it copies over your code and exposes port 80. And then once it copies, like it tries to build it. After building it, it publishes it, and then after that it creates like an entry point to your application. So it's a very simple one, like Docker file that containerizes all your code, which is part of this solution, and runs it as a Docker container. So if you look at so what I do is if I'll show you if I can if I do Docker images, then it shows all the images running on my machine. So right now you can see like there are no images running on my machine. So if I want to Dockerize this, what I do is Docker build tag.
And when you're drafting this, when you're containerizing that app, like you can test it all locally just within Docker itself, right?
Yes, that's what I'm doing actually.
Yeah.
So this Docker build, so what I'm doing is I'm trying to build a container out of this this Docker file. So when I mean, I can specify location of the Docker file, or I can specify a dot. Then it looks for Docker file and Dockerizes it. So once I do that, so it pulls out all the you can see like it is pulling the image from of the Microsoft image with .NET Core 3.1. So while this is doing, any questions on the Docker file?
So how long does it usually take? Let's say you started the build, right? It's just a sample, AKS sample. How long does this process would?
Probably a minute, or not too long. I mean, it depends. Obviously, it depends on your code and stuff. But then this one, I mean, you could see like it'll be done in a minute. So. So yeah, so now it's done. So it built the Docker image. If you go into Docker images, so you can see here it built the AKS sample app with the tag latest image ID, and I mean these are intermediate Docker images that it pulled. But then this is where our AKS sample app is where our code is running. So let's say you want to see it running, right? So what I do is Docker run. So you can specify the port where you want to access. And I'll take this. latest. So now it's running, it's up and running. So if I go into my browser and type in localhost 8080, it shows off my web page. So right now, so what's happening is our code has been dockerized and deployed into Docker. Like so this part of application now the application is being served from the Docker image. So now, so what happened? Like, so any questions on this one? So this Docker, so I have Docker software already running on my machine. So so what's happening is like when I deploy, when I run this Docker container, so it uses the Docker software on my machine, and the same thing happens when it's on the worker node. So you have Docker runtime running on your machine. All the Docker containers use that to serve your application. So once we have it, so the next step would be is to push this Docker container into a Docker repository, which I already did. I already pushed into Docker Hub. But then, yeah, so that's the next step wherein you have to push your Docker image into Docker repository. Once it's there, like when you work in production, you don't want to do that this whole thing in manually. So this all thing should be done by your CI/CD tool, Azure DevOps, or like in any other CI/CD tool. So once we have our container running, so now we need to deploy our code into AKS. So how do you do that? So so I'll show you this YAML file. So I'm not sure how many are familiar with YAML, but this is YAML is used as used by Kubernetes and many other software. So all the configuration information is stored, you specify that in YAML, or you can also use JSON. But then YAML. So right now I have two types of components defined. Like I have a service, then I have a deployment. So let me briefly talk about service and deployment in Kubernetes. So deployment is what you specify Kubernetes. Hey, I need to. So what I'm trying to say here is, you can see here the name of the deployment is sample app. This is the selector match label. So I'll touch upon it later. But then, so labels are important in Docker, and then the main part is you are pulling. What you're saying is when you deploy something into Kubernetes, pull the image from the Docker repository. So this is where my image is coming from, and then you can specify some resource limit like memory and all that kind of stuff, and also what port you want that what port you want to expose the container. So right now I'm specifying that I want to expose the application on port 80. And then and Kubernetes uses this deployment configuration to do the deployments into the Kubernetes cluster. And then how do you expose that deployed piece of container? So this is where your service comes in. So this is the configuration for your service, wherein the kind is service, and this is metadata, and the type you specify it as a load balancer. So what you're doing, you're trying to say is so you're deploying a load balancer that is going to load balance. So the selector here, AKS sample app, should match with the name of your deployment. So this is where labels comes in. So you label your deployment, and then you match it with your service. So then service, what it does is it creates a load balancer, which is load balancing your deployment. Again, you specify the port and the target port. So the port is the load balancer port, you want to expose your service on port 80, and the target port is 80 again, because the container is running on port 80. So there are different other types of services, like you have cluster IP, or you can have node port. But then cluster IP is something which is more inside the cluster. So you cannot access when you deploy a application as a cluster IP. You cannot access it from outside. So but anything inside the cluster, they can talk to each other. So that's where cluster IP, let's say you want something a service that talks to the database, you don't want to expose it outside. So you can have it cluster IP. And the node port can be accessed outside, but then it's in part of the VNet, like the virtual network. That's where you can have access from the node port. But load balancer, again, you can have different types of load balancer. You can have a load balancer which is internet facing, or you can have an internal load balancer which is part of the VNet again. But yeah, so you can do that too. So this is what deploys our. So when you run this YAML file, that will deploy our Kubernetes and the service inside the Kubernetes. Any questions? Okay, let me go to the Azure. So this is my Azure portal. So I'll bring up the command dash, and so again, let me bring it up fully. So if you look at resource groups, I just have SAC Azure resource group, and something like Cloud Shell. I think this is used by the Shell, and then Network AG is used by Azure. So I just have SAC Azure as a resource group. This is where I'm planning to install all my stuff. So I go into Cloud Shell. So let me make sure that I'm in the right subscription. With me, I just have only one subscription, so I just have. That's why you see, if let's say you have multiple subscription, make sure that you're in the right subscription. So since the resource group is already created, so why, so there are two ways you can talk to the Kubernetes cluster. So one would be using your Cloud Shell, or you can use the PowerShell. But then the reason I picked this is it has all the tools that I need already installed in it. I need a tool called kubectl, so that's already installed. So a lot of things are already installed. So that's why I picked this over going through PowerShell. But then yeah, you can have locally and then use it to deploy everything into Kubernetes. So let's quickly. So what I'm trying to get is what are the Kubernetes versions that are already installed in AKS. So you can see so AKS supports all these versions up through 1.18.18. So these are the Kubernetes versions that can run on your again, let's say you have your cluster running on a lower version. Let's say I have it on 1.16.3, and again, you don't have to worry about upgrading all that kind of stuff. So that's all done by Azure for you. So so you just use what version you need and then go from there. So let me quickly create a cluster. So what I'm trying to do here is I'm creating a Kubernetes cluster. So the name is AKS sample app cluster. I'm using Kubernetes version 1.16.3 and location is West US. I'm creating and the resource group is this. The node count is 2. So what I'm trying to say here is like I want 2 nodes, 2 worker nodes, and then your generate SSH keys is like so what it does is it creates SSH keys and puts it on your profile. So let's say you want to log into those machines. I use those SSH keys. So so I run this command. It takes some time, but so this will deploy the cluster for you. So it's running. Probably it might take like 4 or 5 minutes, but so you would see it creates some resource groups and all that kind of stuff, and all the all the components needed for Kubernetes will be created. But yeah, so this is any questions so far? Any thoughts or?
Hey Uday, if this is going to take 4 or 5 minutes, I have a question
Yes.
that maybe you can go back to. So back when you were building the Docker image on your local machine,
Right.
If you can go back to your Visual Studio, I was curious. So I see. So it was in the Docker image or the Docker file.
Mm-hmm.
So I saw that you did that, and then you tested, and then when you tested it locally on port 8080, it brought up a web page, and I wasn't
right.
Like which line in here brought up where you put that web page in? Where was that?
Oh, so not in the that's not in the Docker file, right? So this Docker, so this whatever this code in the Docker file is, it's going to create a Docker file and put it in your Docker images. So and I run a command, Docker command that will do it for me. Like let me show you. So this command. So Docker run itrm port 8080 AKS sample app. So what I'm saying here is like, asking Docker to run my Docker image, this AKS sample latest, and then so what I'm trying to say is the port 80 of the Docker image, I want to use port 8080 on my machine to talk to the port 80 on the Docker. And then this RM tells me that like, once I'm done with the Docker container, just delete it, remove it. So
yeah. So what I mean is maybe I didn't do a good job explaining what I was asking.
oh, sorry.
So when you brought up the port the page on your local machine to test it, it brought up the SAC Azure group,
right.
Like the HTML page.
Right.
And so I was just wondering where you put that page into the Docker file, or like how it knew to serve that page to you.
So that's the part of like, that's part of my code. Like, if you go to the pages here, like, I defined all this CSHTML, these razor views. So this is where my code is. So what Docker file, like, what is Docker file is doing is it's building the code and publishing it to Docker. So, and then you define your entry point here, right?
Can I help you with that one?
Yeah, go ahead.
Yeah,
Sure.
Basically on line 11, we are compiling, we are building the application. Which application? The one that we have on the left, the .NET Core. And then on the line 14, we are publishing that artifacts that were created on the build process and put it inside of the Docker image.
Right.
So that image, that code is being exposed through the port 80, line 3.
Right.
And then when he is executing or when he is running the Docker run, we are saying that the local computer port 8080 should point to the port 80 inside of the Docker file.
Yes.
So basically that is kind of the process on it.
Yeah.
Okay.
Sorry,
cool,
yeah, I didn't do a good job of explaining, but that's what is happening. So it publishes the code to the Docker container, and then your Docker container is serving your application, right?
Okay, thank you.
Yeah. So
one extra thing. Sorry, one extra thing.
Yes, go ahead. Please.
Line 19 is the one that is doing the exposure.
Right. Right.
Line 19 says that it is saying that AKS sample app DLL should be served as a .NET application inside of the Docker part. Just to finish
Perfect.
about the idea.
Perfect. Yeah. So any other questions? Yeah, I know it's a lot of information, but but yeah, please feel free to ask any questions. I'll be happy to answer. So let's see what's the status. So it looks like it built the cluster. So it finished building the AKS cluster. So if I go here, refresh it. So for whatever reason, so we have a new resource group created for a cluster. So on SAC Azure resource group, what we have is a sample cluster, and then all the resources for this cluster are in a different resource group. So if you go here, you'll see all the it has Kubernetes load balancer, what is the VNet and route table and all that kind of stuff is inside your cluster. So if you so kubectl.
Can I just share my favorite?
Yes.
I don't know what you want to call it. It's not a hack, but I always do k equals kubectl.
Yeah. So you're doing an alias, right?
Huh?
You're doing an alias.
Yes.
Yeah, I know. Yeah, I didn't want to do this in this. So yeah, so I just want to show the whole command itself. But yeah, so you can do an alias on all these commands, and then instead of typing the whole commands, you can use the aliases short form of your commands.
I think Uday took a page out of the how to do Kubernetes hard book that you were talking about, Kyle. Whatever it was, the hard way to do containers.
Oh no, this is. Oh man, this is.
No,
I'm kidding, of course.
For another 48 hours.
Yeah. So.
But I mean, this is kind of the reality of it,
Right.
Yeah.
You can't be afraid of the terminal and.
No.
Yeah, your terminal is your best friend actually when you come to Kubernetes, once you start using it. Yeah.
By the way, I did put a couple of links into the chat here from Microsoft Learn, all about the different learning paths that we have on Azure Kubernetes Service and Intro to Kubernetes, AKS, Kubernetes on Azure, as well as there's a full workshop learning path that looks pretty cool too.
So yeah.
Awesome. Thanks, Rick.
Awesome. Thank you. Thanks, Rick. So now what I did was I tried to when I tried to talk to my Kubernetes cluster using kubectl get nodes, it didn't let me talk to it. So I need to bring in credentials. So there is a file called kubeconfig. That's where all your credentials are stored. So I pulled those credentials from my Azure using the command I used. Now if I do kubectl get nodes, so now this will show up your nodes are those worker nodes. So this is 1 and 2. So since we defined 2 worker nodes, so it created 2 nodes for you. Let me show you kube. So this is your namespaces that we were talking, right? You have the kube system namespace. This is where all your Kubernetes stuff is stored. Kube public is something that is that you want to expose it publicly, even though people are not authenticated, that you store here. So I'm not sure why they used node list. I never used it, but this is another namespace. And if let's say you don't specify any new namespace, let's say you don't want to create any new namespace. So if you don't create anything, they go by default into their default namespace. So right off the out of the box, you have 1, 2, 3, 4 namespaces. And then let's say you want to create the namespaces I was showing in the presentation. So all those namespaces would be you can create it here. And then So now we have our Kubernetes cluster set up, but we don't have our code yet. So what I did was I already copied over the YAML file inside in my cloud in my cloud shell. So if let's say you want to go look at cloud shell, so this is the, so what I'm trying to say here, like the kind is deployment, the same thing, like what we saw just before, like you have the deployment, you have the service. Right now I just have 3 replicas, of deployment, and then you have services. So if I go out of this, so let's say get. So this, if you look at here, so in the default namespace right now, we just have one service, that the Kubernetes service. So let me deploy this first. So kubectl apply. So now, so this is as simple as this. So what I did was, so I used that YAML file which I just showed you, the deployment and service, and then do a kubectl apply. So once I do that, it says like your deployment and service are created. So again, if you go back and look at my namespace, you can see here I have 3 pods running because I wanted to have 3 replicas. So so this is pod number 1, pod number 2, pod number 3, and each pod would be running inside a different in a different node. Let's say you have, like right now, since I have 2 nodes, so one node will be having two pods. But then let's say you want to have highly available system, like let's say you have, like you define like 4 nodes and 4 pods, so your application would be running in 4 nodes and in those 4 pods. And you can see here it says like it's the container status as running and then 1 of 1. So what it means is like your pod is having 1 container and 1 is running. And in the service, like you can see here the AKS sample app, that is a type load balancer, so that's deployed. So this is the cluster IP. Cluster IP is the local IP for the Kubernetes cluster. So any service that is running inside the Kubernetes cluster would see this cluster IP. But then, so this is your public IP. So if I go to this public IP and see what's there, so my Kubernetes, my application is deployed into Kubernetes.
Hey,
again.
So the where was it that you defined the replicas? The number of replicas, was that in the YAML file?
Yes. So if I go, so you can see here I have the 3 replicas here, right?
So correct me if I'm wrong, but this is one of the cooler things about Kubernetes, right? So like if you say 3 replicas and you've got whatever 3 or 4 nodes running, if one of the nodes goes down that was running one of your replicas, Kubernetes will automatically spin up that lost replica on another node that's still available without you really having to do anything.
Right.
So that's pretty cool.
Yeah, so it does all the, like like those, that kind of, so that's where your Kubernetes comes in, like that's where your brain, that's the brain that is running. So it orchestrates, like it makes sure that the nodes are up and running, it makes sure that you have the number of pods running, all that kind of thing, like it does automatically for you once you deploy it there. So all you do is specify like how many replicas you want, like all that stuff, and Kubernetes tries to make sure that it does all those things for you.
Question here, Uday. Is this a Docker Compose YAML file, or is only for Kubernetes?
These are all Kubernetes. These are not Docker Compose.
Okay, perfect. Thank you for clarification.
Yeah, Kubernetes uses this YAML file to create the services and deployments.
Crystal, thank you.
Sure. So this deployed our Kubernetes. So I know it's a lot of stuff, but then let me show you this actually. Easy. So let me I'll show you. Let me open a new Cloud Shell. Download. So this is your Kubernetes dashboard. So whatever I do using command line, Kubernetes has this cool dashboard, which shows you everything inside your cluster, right? So what happened? I hope it stays. But yeah, so you can see here the pods. If you go into pods, it will show you like what are the pods. Like there are 3 pods running. What is their CPU usage? What is their memory? Like if you go into pod, then it will show you like what are the containers running in the pod? What are the events? Like you can see this is the image that is running on my pod. So all that all that information which I can get through command line, I can get using this dashboard. So this is more of like visual representation or graphical representation of your whole cluster. So it shows you what are the namespaces. Like I showed you the namespaces, right? Like these are the 4 namespaces that are running. Like the nodes, these are the 2 nodes that are running. What are the cluster roles? So these are the roles that Kubernetes uses to authenticate people. Like all that, like storage classes, like persistent volumes, like everything, whatever you can do using command line, you can view using your Kubernetes dashboard. So I think that concludes my demo actually. So again, so this is what I did was just created a simple application and Dockerized it, made container, push to the repository, and then push to Kubernetes cluster. There are other things like you can have a service mesh. You can have CI/CD. You can have, there are a lot of other topics, or like there are a lot of other additions on Kubernetes. But then this is like like basic installation of like Kubernetes, and then pushing your application into the Kubernetes cluster.
Cool. Thanks for that.
Sure. Now, let me quickly show the cleanup also. Like, let's say you want to clean up all the stuff you did. Like, what you do is, so you did an apply. So all you do is just do a delete, and then it deletes all the parts and all the containers and everything like for you. So it's pretty cool. Like it's pretty neat. Like think like what it does for you. Like it replicates the containers or auto scales it, deletes it. All that kind of stuff. So any questions, thoughts?
I think we're just going to hire Slalom to come and set this up. It's pretty cool though. I'm never touching it.
So, yeah, I mean, I might add too, just because I don't know that we mentioned it, but and forgive me if you did, Uday, but there's several other services within Azure you can use to run containers.
Right.
So if you're still at the stage of, hey, I'm just trying to containerize one of my apps, maybe I've gotten it to run on my desktop or my laptop, or maybe I want to toy around with running it in like an Azure app service, or there's other ways you can run a container before you get to the point of, all right, I'm ready for Kubernetes now, right? Like I need that extra orchestration and availability, and so that's just something to mention in case you're out there, doing homework or whatnot.
Yeah. Yeah, it's not worth it. Like, let's say if you have like 1 or 2 microservices, maybe, I mean, it's overkill. But let's say you have like 20, 25 services, like, then your Kubernetes will come handy. But let's say you have like 1 or 2 services, then there are other services where you can run your containers. Any other questions, thoughts?
No, thanks, Uday.
Thank you.
Sure. Yeah.
Yeah, great session.
And thanks everyone for joining and hanging out.
Yeah, I know. Thank you, everyone.
Well, as soon as we can, we'll announce next month's event, and hope you guys can all join us again, especially like the just, kind of some of the informal discussion and stuff at the start of the presentation. So yeah, thanks again, everyone, for joining.
Well, and Kyle, maybe before we drop, I mean, I know we've got some ideas for the next workshop or for the next user group, but are there topics that this group would want to see us try and work towards, just out of curiosity?
So without, go ahead.
Okay. I mean, it would be great if we have some kind of any session like experience from Uday or something multi-container approach. For example, I'm one of the working on 350 apps in my microservice, my application. I mean, now I was planning to move to the Azure AKS. I mean, that is the reason I joined this one. I want to look at this one, how the things other the industry peers are doing. I mean, I was very hard to maintain. Right now, I have this 4 VMs running with 400 gigabytes and all this one memory around 100 Tomcat instances and 50, 60 Spring Boot apps, embedded Tomcats and all running scattering over 350 total. I'm in the PubSub data integration platform. I'm now planning to move to this one, right? I mean, I want to plan to whether I need to have a monolithic-based application or I want to the multi-container approach, this Kubernetes AKS. Something, if you guys have any use case or some kind of discussion, it will be great. I mean, and also something around the Prometheus or anything, also AKS monitoring, there are advanced, right? Something.
Sure,
Okay.
sure. I think that's more like a deep dive, right? So yeah, we can, yeah. Sure.
So I was going to say, Rick, without me provoking it, there was a couple indirect votes for Azure DevOps before you hopped on today.
Okay.
So that's good.
Perfect. Well, we may just have the cure that ails that then coming.
Nice.
So so I've been talking to the GitHub team, and obviously we're gonna be merging what we're doing with DevOps and GitHub, and then that brings up questions about what about Visual Studio and what about TFS, and so I was thinking, how do we maybe pull all those stories together and help kind of crystallize where we're going? And it should be interesting because we have Ignite coming up next week. I don't know if anyone's planning to attend that. With COVID, obviously we've opened it up to be virtual, so it's a lot easier to get into the sessions this year than it maybe would have been in other years. And I'd anticipate there being some interesting announcements coming up next week on that front too. So we can report on some of those.
Nice. Yeah, that'd be good.
Yeah, I saw an email about virtual swag for the reignite.
Virtual swag.
Yeah.
Yes.
Hey, I have a question for everyone that's still here. How do you guys feel about the 6:30 time? Does it work out? Would it be better if it was at like 4:30, or does that conflict too much with work? What's everyone's thought?
I think 4:30 would be early for me, but anytime after 5:30, 6 should work. Yeah.
Yeah, me too.
Okay. Cool. Yeah, and we originally picked this time because Eventually we'd like to be able to have these in person, and still virtual for those who can't make it in person. And so having it at 6:30 was going to give people time to either get home, get to one of the wherever location we end up having the meetup. So that was kind of the reason behind that.
Yeah, we launched just in time for a nice pandemic. Just throw things awry.
Oh, well. Not the only thing we launched during a pandemic, Rick.
Yeah, good point. Yeah.
All right. Anything else?
Really appreciate the content, Uday and Josh and Kyle for setting this up. And I personally learned quite a bit here in that dashboard visualization of what you got. I hadn't seen before, Uday. So that the last bit there at the end was pretty cool, actually. Like I said, I hadn't seen that before. So thanks.
Yeah, sure.
Cool.
Thanks, Rick.
And you guys, I'm sure there's a way through the meetup group to, if you want to send a message or post something on the discussion board, like any feedback, ideas, anything you guys want to reach out and share. I know, like, George, I'm going to reach out to you about DevOps.
Sure.
So,
Sure.
All right.
Cool.
Yeah.
Good. Thank you so much.
Thank you for
Thank
joining.
you, guys.
Yeah.
Thanks.
Have a
Have
good night.
Cool.
Yeah.
You
Bye.
too.
Take care, guys.
Thank
See y'all.